All right, kids, I'm not going to lie to you. This lesson's a big deal. Okay, this section 9.5 is going to teach you a lot of shortcuts that you'll see the rest of the year, and this is common stuff in like SAT and ACT test questions as well. So in this opener, we're actually going to derive some. I'm going to do a little derivation here. So given that you have an equilateral triangle, we'll call that ABC like that, with altitude AM and a side value of 2x, okay? You're going to have to find AM. So, so what we have here is this. This is what we're given, okay? Now remember, this triangle is equilateral. We know that means all angles are 60 degrees, okay? But the altitude to the base of an equilateral triangle, that creates two congruent triangles. So this is actually 30 degrees up there on both sides. And this altitude is also a median in an equilateral triangle. So if this is 2x, this is going to be x. So let's go ahead and find AM. Okay. So let's use Pythagorean theorem. The hypotenuse squared, don't forget to use parentheses, equals leg squared plus the other leg squared, which is what we want to find. So that's 4x squared. That's equals x squared plus am squared. Move the x squared over. Now remember, we want to take the square root now, right? To find am. Well, the square root of x is just x. The square root of 3 is square root of 3. It's not something nice. So there it is. The altitude is always going to be whatever this x value is times root 3. Now, what we've just derived is we've derived the relationship in a special right triangle, okay? In a 30, 60, 90 triangle in this case. So you see how we've created this 30, 60, 90 triangle. What this means here is in any 30, 60, 90 triangle, the hypotenuse is always going to be twice the short leg. Remember, the short leg is the one across from the 30, okay? And then the long leg, the one across from the 60, that's always going to be the short leg x times root 3 every time. Makes life real easy. So here we'll kind of sum it up. In a 30, 60, 90 triangle, we're going to have measures like this. Okay, so if this is an 30, 60, we call this 2x, that's x, this is x root 3. That's what we just did. Now we can do the same proof in a 45, 45, 90 triangle. If GE is x, and these are both 45, that means it's isosceles. That means that's x as well. So here, you don't have to take my word for it. We'll prove it. Leg squared plus leg squared equals hypotenuse squared. That says go, not 60. So that's 2x squared equals go squared. Take the square root. Square root of x is, square root of x squared is x. Let me fix that. Looks, there you go. So this is x root 2. So in a 45, 45, 90 triangle, the sides are always in the relationship of x, x, x root 2. The legs are going to be the same, of course. And then the hypotenuse is going to be whatever the leg is times root 2. Okay? So this is huge. Again, you're going to see this for years. All right, so let's, if we know this, we can do some of these problems really quickly. So this is the short leg because it's across from the 30. It says find the lengths of the missing sides. So the hypotenuse must be twice that. So that's 8. And the long leg has to be the short leg times √3. Okay, here you're given the hypotenuse, so the short leg has to be half. There's the long leg. Okay. Here's another one where you're given the hypotenuse. So, the short leg, which is up here, because that's a 30, has to be half. And then this would be the short leg times √3. Now, 9 √3 times √3 would be 27, because √3 times √3 is plane 3, and 3 times 9 is 27. So those are really quick and easy. Now, this one here, it can take a little bit more work, because the side that you're given the side opposite the 60, you're given the long leg, which is the x √3 position. I'm going to show you the long version, and then I'll give you a shortcut. Okay? So what we have essentially is 12 equals x √3. Okay? Now we want to solve for x, so that means divide by √3, right? But we can't leave a radical in the denominator, so we multiply by that. 12, that would be 12 √3 over 3, and 12 over 3 reduces to that. So there is our x, which would be down here. And then, of course, the hypotenuse, we have to double that. So, if you forget the shortcut that I'm going to tell you, you can go through this process. It didn't take long. But if you're given the long leg, guys, you take that long leg. To solve for x, you divide this long leg by 3, and then multiply by √3. 12 divided by 3 is 4, times √3, 4 √3. There it is. Okay, because of this whole rationalizing with the √3, that's what it becomes. You're dividing by 3, multiplying by √3. Here's some 45, 45, 90 stuff down here. Obviously, this has to be 9. That's 9 √2. If that's 7 √2, these are both 7. Now, this is the harder one, similar to the one up here. So I'm giving you the hypotenuse. Now look, if the shortcut up here was divide by 3, multiply by √3, here I hope you realize, because we're dealing with √2, we're going to divide by 2, multiply by √2. If you don't believe me, you can do something similar to what we just did right there. Set 14 equal to x √2, and go ahead and solve. Okay, now a lot of this stuff can be done really quickly, even though some of it is not so quick. Diagonal of a square. Remember, a diagonal cuts a square into two 45, 45, 90s. So if that's 10, this side must be 5 √2. So my perimeter is 20 √2. My area, remember, 5 √2 squared. 5 times 5 is 25. √2 times √2 is 2. So there you get your two answers there. Now we talked about an isosceles trapezoid in a problem the other day, not too long ago. Lower base angles is 60, that's huge. What you often want to do is drop in these altitudes, kids. So here we're creating two 30, 60, 90 triangles. It says legs of 12, upper base of 4. Okay, my computer is wigging out here for a second. Okay, so this is 4. So remember, if this is 12, that's the hypotenuse. So this short thing down here must be 6. That's 6. This must be 6 √3. So you're asked to find the area. This isosceles trapezoid is made up of two triangles and a rectangle. So I would just do the rectangle. Remember, that's 4 as well. 4 times 6 √3 is 24 √3. And then I have two triangles. So that'd be 2 times 1/2. Remember, its area of a triangle is 1/2 base times height. Base, height. So the 2 and the 1/2 cancel. And then, of course, we add these together. And we get 60 root 3 for total area there. Okay. Perimeter. Now, remember, look at this here. You have 3 30, 60, 90 triangles here. Be aware of that. That's 60. And if this is 30 and that's a right angle, this must be 60, which means that's 30. So there's all kinds of stuff going on here. So using this little triangle on the right, we know that 15 is a long leg. So this short leg, we have to divide by 3, multiply by root 3. That's 5 root 3. And then this would be, I'm using the small triangle now, that would be double. Okay. Now use the big triangle. This 10 root 3 is opposite the 60. So that means the short side is just 10, and this long side has to be twice 10, which is 20, of course. Means that's 5. So your perimeter comes out to what? No. Oh, remember it says triangle PGR. Be careful with that. That's a little one. So it's 15 plus 5 root 3. Normally I don't do so much in these videos, but the span, that's a new term. So the span is, you see, it's that perpendicular distance across the figure. You know, you could draw it in like from here down to here, from here through the middle. It's probably going to be easier. So it's a regular hexagon. Now, a regular hexagon, guys, I don't know if you realize this, is made up of 6 equilateral triangles. 1, 2, 3, 4, 5, 6. If you were to connect all these vertices to the center. I'm not going to do all of it, but you know, if the perimeter is 54, that means each side, if you divide by 6, each side is 9. So let's go ahead and drop in my altitude. Remember, it's an equilateral triangle, so I just created a 30, 60, 90. So this must be 9 over 2, and then this height has to be 9. You have to multiply by root 3, right? Now the span, of course, is going to be 2 of those heights together. So the span would end up being 9 root 3. Because you'd have another one of those heights right there if you drew in another equilateral triangle. Now in the octagon, now the reason why I drew in this triangle here, because in a hexagon, you end up creating equilateral triangles. If I did the same thing down here with an octagon, I would not get an equilateral triangle, so it's not as beneficial. So instead, you draw in your span this way. Okay, and check this out. Actually, I'm going to draw in a span here as well, and here. Now, if you take 360 degrees and divide it by 8, well, sorry, I had a total brain lapse there. I mean, this thing is getting a little bit ahead of where we are. We'll talk more about this stuff in a future unit. But each angle, and we'll talk about how you can calculate it, each angle of a regular octagon is 135 degrees. So I haven't shared that with you yet, how to do that. So the reason why it's important here, though, is this span is going to be perpendicular. So if that's 90, that means this angle here is 45, you see? And we just created a 45, 45, 90. If I divide this by 8, I get 6. That means that's 6. That's 6. That's 6. Okay? Now, if that's 6, this thing here, of course, has to be what? 3 root 2. You'd have the same thing as well down here. Now, this is a rectangle. So my span is going to be this sum, 6 plus 6 root 2. Okay. Again, I know we haven't talked about how to do that yet. We'll do that later. Okay. And this one's tricky. Okay, find the perimeter of triangle ABC. I will show you what most students do first is, and this is not a bad idea, okay? And sometimes you'll have to do this. They drop an altitude in here. And they do create a 30, 60, 90 triangle by doing that. But you see, we have a 30, 60, 90 triangle with no side lengths because we don't know how it cut the 24. And this is not a special right triangle. So that doesn't work. But don't forget about that. Remember, because you might use it for some other problems, sometimes we can draw in stuff outside of the figure, right? Drop an altitude, extend the base. I just created a big 30, 60, 90. Not only did I create a big 30, 60, 90, if this whole angle is 60, that means this must be 45. I also created a 45, 45, 90. So that's kind of cool. And looking at the big triangle, hypotenuse is 24, so this short side must be half that. And this thing would have to be 12 root 3. Okay. Now remember, if that's 12, this is 12. That means this is 12 root 2. Remember, we have to find the perimeter triangle ABC. So I just need this piece here. Now remember, BC is going to be what? That whole bottom, 12 root 3 minus 12. So my perimeter, I'm having trouble spelling right now. My perimeter would be what? I'd have 12 root 3 minus 12 plus this 12 root 2 plus this 24. So I would end up getting 12 plus 12 root 2 plus 12 root 3. Because I have this, negative 12 and 24 is positive 12, and then I got this 12 root 2. So don't hesitate to draw on stuff outside of the figure.